Welcome to this video. Today we are going to talk about the ARIMA model. So ARIMA stands for Autoregressive Integrated Moving Averages. So this video is, or the purpose for this video is, if you are a complete novice or if you are a complete rookie in machine learning, you will be still able to understand what example I'm going to show you. So here we are going to follow the entire process with a problem statement for with ARIMA model for time series forecasting. Now, if you want to know what ARIMA is or what it does, I'm just going to leave a link in the description. So this particular person explains in his blog, very simple, what ARIMA is. So it's called ARIMA for Dummies. So that gives a great example or insight on what the model stands for, right? So let's just get into our statement and building our model. So I'm using Jupyter Notebook over here. I'm going to import some files. So let's just look at them. So first one is the NumPy, pandas, matplotlib, seaborn. So pandas, we need data frames, so we are importing it. Matplotlib, we want to draw graphs in our notebook itself. Now this function I'm using because I want to show plots in this particular Jupyter notebook. Now from ARIMA, we are going to import ARIMA from stats model. So stats model we import ARIMA. Also we import the simple exponential smoothing and exponential smoothing from stats model itself. So these are really important. Then linear regression, mean square error, these both we are going to download or import from the sklearn packets, right? So from sklearn modules. And we also need the do to date time function, so that also comes from the pandas module itself. So these are really important, the ARIMA one, the mean square error and the linear regression. So those are really important modules, and we need to import them, right? If you're wondering, you can get this particular code and this Jupyter notebook file in the description, right? So it's available on my GitHub and you can download it from there. Now let's just look at the problem statement. So what we want to do is we want to forecast the GDP per capita per country for the next 6 years. So in this case I have taken 6. You can change this model and you can do it 7 or you can do it 10, but right now we'll see for the next 6 years, right? Okay, the next step is we need to load our data. So what we'll do is we'll load our data from CSV. Now this CSV file is available locally, right? And we are going to use Latin 1 as an encoding. So this also file is available on my GitHub and you can download it from there. So we are seeing two things over here. First is the shape one, right? We are going to see the shape of our data, and the second is we are going to see the head of our data, right? So shape returns how many rows are there and how many columns are there, right? So we have around 27,000 rows and we have 8 columns. And to see the first 5 values, I'm just gonna print head so we can see the columns and values here. Now this is clearly observable that we need some data pre-processing in this particular CSV file, because we can see the flock codes and flags, they have some null values. Also we need to check if there are any other null values present in the other columns as well, right? So what I'm going to do is I'm going to use a isNull function and I'm just going to sum the raw data. So here I'll get a sum, so aggregation of the null values in each column. So we can see the value column over here has some null values, so around 2000 null values we have, so we will drop them. And the last 2 columns, there are no use to us, so we will also drop them, or we will exclude these 2 columns, right? So clean the null values, so drop NA. So we are going to use the drop NA function where the subset value is value, right? So for value we are going to drop the null values and store it into our raw data. So this value, so these null values are gone over here, And secondly, we don't want these two columns, so we are just going to keep the columns which we want into raw data, and we are going to use that function to recheck if we have null values in any particular column or not. So there are no values, there are no null values, so raw data is the data which we have right now, which is cleaned, right? Again, one thing we can do is we can check the unique values in each column. So for this, I'm simply using for column and raw data. So for each column in this raw data, check the unique and return me the length. So that's the simple function. We use dot format function for column and unique sum. So column will go into this parenthesis, so demo indicator location, and unique sum will go into this parenthesis, giving us the unique values. For example, country, we have 233 unique countries in our database, right? Moving towards the data which we need, so we need to filter out the data, and we just want the GDP per capita, current international. So we had multiple indicators. Okay, so from the 27,000 data, we have multiple indicators, but in this case we are just interested in the GDP. So from indicator, we'll filter them out, and we are going to store it in our forecast data. So our forecast data is going to have this only. Now what have these countries are been, so I remove these countries because there are some errors which we are getting, so that's not important right now. You can just remove them out. Okay, so we just put not in front of it to remove it. Is in, and we are just putting not sign in front of it, right? So this is the final data. You can see the indicator, we only have the GDP versus the indicator. So we had fertility and a lot many more data, so we have just filtered it out to consist of only GDP per capita. Moving on, we are going to live in the columns again to only which we need, right? So we don't need this first demo column. I also don't need the indicator right now because I know only GDP value exists. So I'll just keep country, time, and value. We have the country, we have time, we have the value. Now here you can easily see that the value is not in date time format, right? So I'll sorry, no, not value. The time is not in date time format. Now most time series model requires that data structure to be in date format. So I'm going to convert time over here. So from our data time, we say forecast data time as type string, so convert it into string, and then I'm just going to add 01 and 01 to it to convert it into date format, right? Now this is not really important in case we are analyzing, but we need it in terms of date format, so I'm converting it. And then finally pd pandas function I'm using over here to date time, forecast date time. So this forecast date time is being converted into to date time, and we can see the result over here. It's been converted, right? Now coming to the splitting our raw data for training and validation. For this, let me show you a quick graph. When you're working with ARIMA model, you need to make sure that your time series is stationary. So here we can see the time series clearly stationary. Now stationary, I mean that the mean and the variance is constant over several intervals. So if you're calculating mean at particular intervals, it's gonna be constant throughout the series. Now the link which I have posted down in the description, ARIMA for Dummies, it does explain what is stationary versus non-stationary time series, so you can check it out and get deep insight. Just for now we'll consider this stationary time series. So this is not a CSV file, but this is something similar to it. So now what I will try to say is we need to have a training data set as well as the validation data set, right? So training data set or testing data set, and we'll have an validation data set. So what I'll do is I'm going to split data, I guess, here. For example, this is just an example. We'll split data over here. This will be our training data, and this will be our validation data. So now what we are going to do is, in ARIMA, the previous value or the forecasted value are been forecasted based upon the previous values, right? So what we'll do is we'll build a model just for the validation. So we'll test if our ARIMA series matches with this particular trend, right? So we are just validating and checking it. So if it's not matching with our trend, suppose we have ARIMA series which comes out like this after testing, then we need to fit it to match this particular trend. And once this particular trend has been matched, what we'll do is we'll predict for next 6 years in our case. So for next 6 years, we'll predict the future values. So in 1000, we have our case, we have examples. So if it's for example 21, so we'll have 2020, 2022, and so on. So we have years on the x-axis, and y-axis in our case we have the GDP. So hope that's clear. So training data set, validating data set, and this will be our forecast. So first we need to fit it, and then we'll convert it into our forecast. So I hope that the example from the stationary data set was clear. So that is exactly what we are doing here right now. We are splitting the raw data in training and validation, right? So our series is based on time. So what I'll do is, if the date is below 2012, so we are going to put them into train, and if the series is greater than or equal to 2012, 1st of Jan 2012, then I'm going to put it into X valid. Like, you can use any variables, but these are pretty straightforward, right? So here you have your train data, here you have valid data. So once you have put your data into respective variables, you can again check the shape of it. So X train shape is 3000, right? We have close to 4000 rows, 3 columns, and validation we have close to 1000 rows and 3 columns, right? So we had our training and validation data. So next, again, these are the links. You can find them in this same Jupyter file on my GitHub. So ARIMA for Dummies. This really explains concepts in simple format, or time series seasonal ARIMA, that is SARIMA. You can also get that information, but we are not looking at seasonality over here. Again, remember, this is the stationary data, so we are not it's not a non-stationary data, so we don't have to convert anything over here. But most of the time the data will be non-stationary, so that time you have to convert that particular data into stationary, right? Moving on to next is, we are actually running the ARIMA, and in this case we'll just run ARIMA for only one country. In this case I've considered United States. So firstly I'll filter the train data based on the USA. So what do we have here? We have training data, but we have entire training data of each country. Now I don't want that. I just want United States of America from country into our training data. So what I'll do is, I'll take the extrain country, which is equal to United States of America, and I'll put it into US variable. Okay, so that will be our first data frame over here, right? And in US2, I'll just take time and value, because this is the same thing which we did over here too, right? So what we did is, we know already the data is about GDP, so we are not again adding that column. So same thing over here, we know the data is again for United States of America, so we don't take that column, right? So we just take time and value for this country. So training data, United States, we have time and value column. For valid, validation data. Again, same for United States, we have time and value, right? uh, let us just go back to the series to understand this quickly. Okay, again, looking at our stationary time series, what we had over here was, this is our train data set, this was our validation data set, and here we are going to have the forecast of ARIMA, right? So what we did is we put US2 over here, right? And so that's the US value over here, and US validation is gonna be over here just to validate our ARIMA model. So that's the two data set which we have: training for United States and then validation for the United States. So that's our US2 and US validation true as shown in the graph, right? Now what we are going to do is we are going to set index. Now this is something you need to do to run the time series model, right? So I'm going to set index as true. In place is equal to true. Why we put in place is equal to true? Because we want these changes to happen in the CSV file also. So we are going to apply index on both US test and valid data, right? Validation data. Now what we are going to do is we are going to set index for 6 years. In this particular example, we are going to do 6 years, okay, going forward. So this is again the data. Let me just pull it again over here. Yeah, this one. So what we are going to do is we are going to work on 6 years. So we want to forecast for 6 years, but these 6 years are not present in our current CSV file, right? They don't exist over here. So what we are going to do, we are just going to index them for now to 1 to 6. Okay, we're just going to index them as years. So we'll have 6 years over here, so we can select them later on to forecast. I'll repeat, we don't have these years, these future years we don't have into our databases. So what we are going to do is we are going to create an index. Okay, we are going to create an index for them, so we'll use them for forecasting later on, right? So creating the index, so we can use the manda function of date range. So index of 7 years. Okay, I need to change that to 6 years, and I need to change that everywhere. Yes. Yeah. So period or date range US2. So what is US2? US2 is this value. So that's our training data set. So for training data set, I'm going to use index, right, of period 6. Now this date range function is available, so their definitions is available on the Python website, so you can find the documentation. So it takes many parameters, but I'm going to set parameter AS. So A is annual frequency, right? So it's gonna take the first index. For example, it's gonna take this time, so 1/1/1990, and it's gonna add 1 year to it. So it's gonna be 1/1/1991, right? And it's gonna do it for 6 times. It's gonna do it for 6 times, and we are going to store that 6 times in index 6 years. Okay, let me just run this. Right, I guess we can check this too. Yeah, we can check this too. Here we have index 6, and you can see we have future values. So what it did, it took 2010 and it added 1 year. So 2011, 12, so on and so forth up till 2016 we have in index 6 years. Now next we are going to run ARIMA with PD and Q. For again PD and Q values, you can check this link over here. ARIMA for dummies. It gives a simple explanation of what PD and Q stands for. Just to quickly give a review, P is something which is related to the um, AR model. So AR model, then D is the integrated value, and Q as MM moving averages value, right? So these are called as lags, of how many lags, previous lags you are using. So for example, if you are working with months, then how many previous months or how many previous lags which are you using to calculate the future uh, or, or the forecast values, right? So that those are the lags, and these are the moving averages Q, right? But again, you can check this article out to get more knowledge about it. Checking the model ARIMA. Now this is something which is going to be remain common if you're building any ARIMA model. These two steps and this passing the index are going to remain common. Now what we are going to do is we are going to firstly select any random three values, right, for what PD and Q. Okay, we are going to select any random values. So just consider 0 to 2 is random values for this US2. Now what is a US2? It's our training data set, right? So for our training data set, I'm selecting random three values for PDQ, and I'm going to fit that model. I'm going to fit the ARIMA model over here, right? Next is making prediction on the next 6 years, okay, without index first. So what we are going to do is we are going to fit that model for next 6 years. We train that model. Okay, here what we are going to do is we are going to use US2, so that's our training data set, and now we are going to work on those 6 next year which we already prepared, right? And I'm going to store that forecast, or I'm just to store that fit into fcast1. So that's our new variable over there, fcast1. And then I'm going to pass the index, because if you're just going to run fcast1 over here, it won't have an index, it will just have some sort of values, right? So we don't want that. We want a index attached to it, right? So fcast1, and then we pass the index and we rename that fcast1 as ARIMA. We can see that later over here in this figure, right? We see the fcast1 named as ARIMA, right? So that's done. Plotting the prediction is pretty simple. Fcast1 is our first plot. So fcast1 is the red line over here. Then USV2 is the actual value. So this is part of our actual data. So the blue line is actual part of our original data. We are not changing anything in that. Red is one we have predicted. So right now I've kept 0 to 2, so I can change it to 3 to 2. So again, 3 to 2 cannot be work because not all PQ combination works. So let's try with 0, 1 and 2. There is some sort of variation over here. 2 2 will be, there is some sort of curve over here, right? Let's choose 2 4. Again, it can throw us an error. That mean square value. Okay, let's just keep it 0 to 2 for now. We'll check, or I'll show how you can calculate this PDQ value, or you can find in the later step. Okay, we have calculated 0, we have kept the random value 0 to 2, and here we have our forecast. Now you can see that this forecast is exactly, so it is a great fit over here. Also you can see the mean square value of ARIMA as 1800. So it is an exact fit. Now I have not always used 0 to 2 as starting point, but this is something we get from a Kaiki information criterion. Now this is really important. This gives us the PDQ value, right? This gives us the PDQ value. Now less the mean square error, the good or fit is going to be, right? This is the mean square error function. We have passed two values. We have passed the US validation values as well as the forecast values. So forecast values I have passed, and this blue line is the US validation values, just to compare it. Now we have the minimum mean square error cause I used the Akaike information criterion. Now what's the Akaike information criterion? Let's just consider we have 5 values from 0 to 4, 0, 1, 2, 3, 4. Now I want their combinations in PDQ. Now I want such combinations in PDQ such that my MSC is going to be minimum and the AIC is also minimum. Let's just look quickly at the finding the best value for ARIMA, right? So this value, first we put randomly, but now we are going to calculate them. Okay, import enter tools. So enter tools, we have product of those values, so we can have multiple products. So 0, 0, 0, 0, 1, 2, 0, 2, 2, and so on and so forth, right? So what we are going to do is I'm going to assign PDQ range 0 to 5. So these are the 5 values. So 0 to 4 will be the values, and we use a for loop to fit that order, right? To fit our ARIMA to that particular order which are in our parameters. So in our parameters we have in PDQ is going to be the product of those 0 to 5 values, right? These two steps are similar to what we have done over here. So selecting the PDQ values and fitting those values. So these steps are going to be similar, except you can continue if those values don't fit. Now here we are not going to get all the combination. It just gives us the combination which has the gives us some sort of AIC values, and in that AIC values we are going to select the minimum one. Now here we can see that 331022 is the minimum one, and that is something I have selected, right? So over here 022 is the minimum one, and I get that particular red line, which is a great fit. Okay, I can also use the maximum. So let's just say 0, 0, 0. Okay, let's just try with 0, 0, and 0. Run it. You can see it's not a great fit at all, right? So this is our ARIMA model, and it's not a great fit at all. Also, you can see 19,000 is the MSC, so that's not good, right? So we select the minimum values, that is 002. Oh, that's not 002, or 022 value, right? 022 value, and we get a great fit, right? In the next video, so this is a two-part video. So in the next video, what we have done up till now is we have the data, right? This is the entire data, and this is the validation data. So in the next part, we'll see how we can include the indexes which we have created, that is 6 indexes which we have created, and how we can implement this forecast into those indexes. Image in front of you is something which we want, right? In the previous part we did fit our model, right? We did fit our model. This red is the ARIMA model, and the blue behind is the validation data, and this is the training data, right? Now what we want to do is we have already created those 7 or 6 index of the future, right? These are those 6 index, and we want to forecast our model for those next years. So let's just see the data. Now this is something which we did in last video. Just to overview, we did random we started with random PDQ values over here. Then what we did is, we don't want random PDQ values, but we want the PDQ values which has the lowest archaic information criterion. So we tried different values in for loops and we got the minimum criterion. Okay, and we applied them and we got it a great fit with the lowest mean square error. So that's good. Now, as we have fit our data for our validation, we can do it for the future 6 years, right? So let's just start with our ARIMA model for the future predictions. First of all, I'm just going to select one country. So in this case, I'm just going to select the United States of America again, right? For seen countries. Now later on, we can add countries, right? So first is United States, second can be India, Dubai, whatever. You can add countries later on. But let's just try first for the United States only. Okay, so for seen countries, so C is United States, right? So first index C in countries, train data, extend countries, C is equal to column. Okay, so our column country will have C, so United States of America. To train data, only have data for United States. Train data 2, we have data for United States, only time and value. This is the same thing which we did previously. We already know the country, so we'll not use that column. So this data is just going to be for United States. So time and value just for United States. Same for validation data, time and value just for United States. This is something which we have already done previously, right? So this is done, right? Then all data. So what we want to do is, we want to get training data. Okay, so this blue line is our training data, thin blue line is the training data, and this dark blue line is our validation data. This is our forecasting. But what I want to do is, now I want to start from here, from starting till the ending. I want that entire thing to be one data, and then we are going to have some future predictions. Okay, so that's what we do. All data will have the forecast data for the country C. So all data, time and value, so the entire data. So we have 3 data over here: training, validation, and entire data. Again, we need to convert date time, because this is something we do for time series. So train data convert into time, valid convert into time. Then I'm gonna rename valid data this as valid data. As we can see over here, that's the validation data, so I have just renamed it as valid data, right? So let's just go above and rename it as valid data, and set index time for our all data too. So convert data and column for train, valid, as well as all data, right? So this is done. Pretty simple up till now. So now what we are going to do is setting the valid for next 6 years, similar which we have done already. Period is going to be next 6 years, and date range we are going to set. Let me just change this again. This is going to be for 6 years, this is going to be for 6 years as well, right? And period is going to be for next 6 years. So I have removed the redundant data over here. I'm just keeping the plotting for validation and plotting for future. So plotting for validation will be color red. So validation, again, valid data. This is our original data. The behind one is our original data, and this is the forecast for validation. This from here till here, it's our complete data, and this is the future prediction, right? That's the plotting future, and that's it. You can, that's your prediction. Now if you want, you can just print this data to CSV. So what we can do is we can concatenate the fcast1, both the fcast1 for future and validation, and we can export them to CSV. Now you can comment down below if you want that to be added in this particular example. I have kept it very simple, but that will be just 2 to 3 lines of extra code, and I can add them uh, in the same Jupyter file, so you can see your exported results, right? So that's the final ARIMA chart which we are getting with our predicted values.